Oh, the reason I didn't upload the notes is because it was 1,000,000 pages of notes about binary. Is that what we did on Tuesday?
Mm-hmm.
Yeah, that sounds right. Okay. So, Java basics. The book's catching up to where we've been since day one. So every program must be enclosed in a class. Think of a class as the name of the program. I don't know if I agree with that. But you break your project up into classes, and each class should go in its own file. It's not strictly necessary that each one goes into its own file, but only one of them can be a public class. So for example, the last time I did a lecture, we have a public class lecture F. If I wanted to stick another class into the same file for whatever purpose, and we're not going to really stick with this, I will create a new project. It's going to give me an error. Class C2 is public. It should be put in a file named c2.java. And yes, that is correct. That is what I should do. If I really, really, really wanted it to be in here, I would delete the word public, but what that would mean is that if there were other files in the project, they wouldn't be able to get a hold of this class. They'd only be able to do that one. The word public means accessible outside this file. Lecture F is outside this, is public so that Java can run it. It can find the main method and run it. If it was not declared as public, then when Java tried to run it, it should produce an error message to the effect of not being able to find main. Now, it could be that it'll work anyways. It did, but if we made it so-called private not allowed here. All right, well, anyways. So, let's make a new project, new day, new lecture. If you're on your laptop, make it an ANT module, an ANT. Okay, so Lecture G. I'm going to remove the class spec. It'd be nice if I spelled lecture correctly without so many E's. And then put the project back. Go away. All right. So the class heading, we should stick the word public class hello. Inside the class, we need to have methods. The main method requires this precise syntax. The only thing we can get away with is changing the name of that variable. It doesn't have to be args. We could rename it. Variable names are just for the user to read. I mean, not the user, the programmer's convenience. So if we went in and we changed that to something else, like Joe Bob, then it would still compile and run okay. And if I wanted to access whatever piece of data that was, I just have to use that as my variable name rather than args. But that's silly, so I'm going to undo that and leave it back as it was. When the Java virtual machine, when the runtime engine launches it, it looks for the main method and begins executing with the first statement inside the main method heading. We use our braces to group things together. A brace is a block of code. Any variable defined within braces is so-called local to that block of code. I'll give you a demonstration of that. Normally we think of blocks of code and local variables as being parts of methods, but you can declare, just for no good reason, and actually there are times when you might want to do this, and curly brace there, declare a variable here, close curly brace it there, and then try to access it. Right, set it to 4 underneath it, x equals 4. That won't work. The reason why is the variable is created within these curly braces, and so it's only available, its lifetime, its lifespan, its so-called scope. I think it's like a rifle, a hunting scope. The only time you can find it is between those braces. Can't find it down here. If we wanted to be able to use this variable here, we'd actually better declare it above the curly braces. We could do that. You know, if we took that and moved it there, then that's not a problem, right? X is still local to this method from there to there, but at least it wasn't defined within those curly braces. Now, it's not a bad idea to declare variables inside curly braces, although usually you do so inside of if statements or while loops or stuff like that. If you just want to declare a variable and you want to make sure that that variable name remains available to use later on for some other purpose, what do I mean by that? What if you needed to reuse this variable and give it a different data type further on, like like a double? Well, we can't do that because it's already declared as an int. But if it was declared inside the curly braces like that, then that variable name is still, in other contexts, available for us to declare. And usually that's not a real strong reason to just go willy-nilly and create curly brace sections of your code. So this is mostly for demonstrative purposes. What if you do the opposite? What if you declare a variable and then inside curly braces you try to redeclare it? Like here we have a double named x, and suppose inside the curly braces I try to give it a new type. That'll work in some languages. It won't work in this language. In C++ it works. C++ goes, yeah, sure, you can go ahead and create a variable named x. You're only going to be able to use it as a string from here to here, and after you get out of there, it's going to be a double again. But feel free. This language doesn't do that. Java does not do that, neither does C#. We're going to wind up deleting all of these pretty soon. Or I guess I could leave that one there and just put a comment to the effect of cannot access x here. X is local to the block of code between the curly braces. So a variable is only accessible normally if declared as part of a method. It's only available within the curly braces in which it is defined. A variable is only, okay, let's say a local variable is one defined in a method. A local variable is only available, is only accessible, quote, in scope, end quote, inside the curly braces in which it is defined. So this is totally fine because x has been defined. Just because we have some curly braces doesn't erase x. New curly braces means we're opening up a new block of code, but everything that's already defined above it still exists. But I am going to delete those. I can't justify leaving those in the notes. I think I can here. So proper style, we've talked about that. You can configure NetBeans to do this, your style of choice. If you like so-called block placement, where the curly braces are on their own lines, you fix that under Tools, Options, Editor, Formatting, Braces. Just make each one on their own line. This is a very common style. However, the people who invented Java expect you to do that. That's why you'll see a lot of code examples out there that do that. On the other hand, the book wants you to do it that way. And I happen to like that style, so we're going to abide with what the book says. So an identifier is a variable name or a class name or a method name. And they do follow the rules that no spaces are allowed, but you can have letters, digits, $signs, which is totally weird, and I know I've already said don't bother doing $signs or nobody will recognize the code, and underscores. So in our code here, we already have a couple of identifiers. We have that one, It could be any combination of letters and numbers and underscores as long as it doesn't begin with a digit. 1, like that, that's bad. But blah, 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 blah. 1 is fine. I accidentally typed in a semicolon, so that's an invalid name. If I put a space there, that's invalid. If I put an underscore there trying to simulate a space, that's totally fine. It's still a good variable name. Methods follow the same rules. We could call this main123, although the program is now broken and won't run anymore, but that is a valid identifier. So is main123. Just 123 all by its lonesome is not a valid identifier. Not strictly because there are no letters, but because it begins with a digit. And the fact that there are no letters in it requires it to begin with a digit. Yeah, I guess we could throw in underscores, but that would be crazy. I wouldn't do that. Your method should have good names, right? Undo all those changes. And the class name is an identifier. So variable names, method names, and class names. Again, this has to follow the rule that it can't begin with a number. If you change the name of your class without changing the file name, your code's no longer going to compile. What if I thought that this really should have been called Lecture H? I started as Lecture G and then I realized, oh, I'm an idiot, it should have been Lecture H. Well, now it's not going to compile because Lecture H, Lecture G, they don't match. So you don't just do that. Instead, you refactor it. You can rename it by refactoring it. There's two places you can do that. One is you can go to Project, find your file there, and rename it with a refactor rename. Or you can just choose the class name, highlight it, refactor rename, and give it the new name. And I could call it Lecture H. I'm going to wind up undoing this. I'm changing it back. It changes the file name, lectureh.java. If I go over here and look in the projects, lectureh.java. And I did Control Z to undo that. So the book recommends using letters and digits only, not dollar signs or underscores. I like underscores because if I start typing in variables up here and having y'all follow along and I'm using uppercase versus lowercase, then inevitably the number of errors increases. Now, since we only have a handful of students, it wouldn't be that bad. So I might actually start trying to pick good variable names. That's called camel case, when you have initial lowercase, but then all the other words in a variable name are uppercase capped. Excuse me, initial capped. Class names, you're supposed to begin with an uppercase letter. That's just a tradition. It's not a the code won't break if I did a refactor and renamed that to something that was lowercase, lecture with a little g. But good programming style dictates that you name all your classes with an uppercase letter. Everybody follows that, so we may as well. That's not like brace placement where some people do it one way and some people do it the other. Everybody does, the class names being uppercase letters. So when we're declaring our variables, you're allowed to declare multiple variables on the same line like that. It would have been possible to declare string first name, comma, last name on the same line. But the problem is that doesn't then let you put a comment on them, right? If you have 20 variables listed on one line, you can't provide very useful comments about it. So it's not a bad idea to go ahead and do them one per line, like that. On the other hand, maybe row and column are so interrelated an idea that it's okay to have listed them on one line as long as they're of the same type. You couldn't declare a row and then make a, something else like last name and make it part of the, go away. Make it part of the declaration. So all the variables on one line need to be of the same type. Java uses equal for assignment. It's called the so-called assignment operator. Just copies the value from the right-hand side to the left-hand side. If you've done other programming languages, you're very familiar with that already, but you can't get away with doing this. oh, I want to put a new number into x, so 10 equals x. That may be a good algebraic statement, but it's not a good programming syntax, because the programming syntax requires that the variable be on the left-hand side and then the expression that is assigned to it be on the right-hand side. So we'd have to make it x equals 10. So that's invalid syntax, must be x equals 10. Here they're trying to display something, and so they're making a message called bonus message. They create a variable called bonus message, and in bonus message they put this part of the string, and then they tack on another value. And so this value will be converted into a string and appended to it. Python's not quite so kind. It would not take that number and automatically convert it to a string to be appended to that. But if we printed out bonus message now, it would say your bonus equals $, and then it would print out whatever 50,000 times 0.02 is. This plus sign is not doing addition, it's doing concatenation. If we come in here and do something similar, string name equals Joe space end quote, or Joe end quote plus Bob end quote, and then we print out the name, system.out.println parentheses name. It's going to print Joe Bob, and it's going to put no space between them. This is called concatenation. It looks kind of dumb having no space between them, so we should tack on a space somewhere in there to make it work. Ooh. I never renamed it back from lecture H, or to lecture H. Something's gone wrong. So I'm going to build it, I'm going to run it, it's going to ask me to confirm that lecture G is the main class. That'll happen if you do some refactoring and you rename your main class to something else. And it did print out Joe Bob. So I could fix that in one of several ways, right? I could just tack on a space there or whatever. But let's create a first name and a last name variable. String first name equals, Mary, end quote. String last name equals, quote, Wilson, end quote. I think that may have been a member of the Supremes. S-T-R-I-N-G, if I could spell correctly, it'd help. Now name equals, quote, no quotes, first name. If I did just first name plus last name, it put Mary Wilson with no space, and that wouldn't look too cool. So I'm going to do first name plus space, quote space quote, or quote space end quote, plus last name. And now if I print the name out, it'll say Mary space Wilson. System.out.println name. Or let's use a printed format, a formatted print statement, a printf to print it out. To print out a string, you use %s. System.out.printf, parentheses quote, my name is %s space %s \n, end quote, comma, first name, comma, last name. And just like when we were printing out numbers and we used %f to indicate the numbers, %f if it was a floating point, %d if it was an integer, %s means string. So that's a placeholder that gets filled in with the first argument. That's a placeholder that gets filled in with the second argument. So printf uses placeholders with formatting don't even know what to call it. Format specifiers, %s to print a string, %f to print a float or a double, and we're always going to use doubles, so who cares about floats, and %d to print an int or a long. Now I kind of wish that you use %d to print a double, right? But no, % and %i to print an int. But I didn't make these up. Guys in 1970 inventing the C programming language made those up. So, and Java rolled with it. So %f to print your floats and doubles, %d to print your ints or longs, and %s to print a string. So let's do one more. Name equals, string space output equals string with a capital S dot format, parentheses quote, hello space or comma space %s period. And after the quote, end quote, comma, first name, in parentheses, semicolon. And let's print that out. System.out.println, parentheses, output, in parentheses. Here we built our display string before calling it out. So there's no quotes at all, right? No quotes here. Instead, all the quotes happened in the line above it where we declared a variable called output and we set it equal to some text. And what does string.format do? String.format just lets us use that placeholder, %s. We wouldn't have had to use string.format if we wanted to do it in a different way. We could have done it like this. There's always more than one way. Why am I showing you 20 ways of doing it? Because you need to see them. Output string output 2 equals quote hello comma space end quote plus first name plus quote period end quote semicolon, and then system.out.println parentheses output 2. Those two chunks of code do the exact same thing. If one way makes more sense to you, if you start to learn to love using %s, go for it. There'll be times when you have to use %s. What do I mean by that? If you want to specify a floating point value and say I only want 3 decimal places, 3 places after the decimal, you're going to use %f to get it to be 3 decimal places long. Doing it like this would not let you specify the number of decimal places. Let's do that. Double space age equals 3.2 semicolon. 21.7, who cares? Now let's make our string equal to that. Output equals capital S string dot format in parentheses quote my dog is %.2f space years old period end quote comma age in parentheses semicolon, and now we can print that output string. So on the next line, system.out.println output. Do you have to build an output string and then print it out like that? No. What we've been doing in the past is just doing one print statement, right? That had all the % signs in it if it needed to be. But this is an option, right? You can build your string and then display it on the next line. Or you could write a method that would calculate and return that string, and then you can print it out. Right? Now we don't have a method named greeting, but we could create one. Where's my closing brace? Okay, this is the end of main here. So I'm going to put a comment that this is the end of main, that this is the end of the class, and I'm going to write a method called greeting. Public static, capital S, string, greeting, parentheses, string S, or string name, doesn't really matter, end parentheses, and on the next line a curly brace, and we're going to return space, quote, bonjour, comma, end quote, plus name, plus double quote, exclamation mark, end quote, semicolon. So let's call the greeting function and print the results out. String, capital S, output 3 equals greeting, parentheses, in parentheses. Maybe I should have made it greetings. I'm getting an error. Oh, because I forgot to put a name in. I need to pass in a name to fill in that name variable. It's a good French sounding name. Bob. There we go. And then we're going to print out that result. System.out.println, parentheses, output 3, in parentheses, semicolon. So here we built our string by calling a method, like a function. It jumped down here. We passed in Bob as an argument, so it filled in this parameter variable. That parameter was used to build our return string, which got returned back up here and stored in that variable output, so that when we printed it out, it's going to say Bonjour Bob. We haven't run and tested it recently to prove that this is all working. Seems to be. Notice that .2f that specified 2 decimal places. If we wanted to be really precise about how old our dog was, we could change that to %.5f. So I just modified that line and I changed the 2 to a 5 and I run it. And now it's 21.700000 years old. If we take the 5 out entirely, if we just make it %f, then we let Java pick how many decimal places to pick, and guess what? It displays 6. Maybe that looks silly. Maybe we only want 1 decimal place. So I'm going to make it %.1f. And I think that'll be my final answer. I think I'll leave it alone at that. Now to round up if need be, right? If this was 0.79, it's going to say my dog is 0.8 years old. So initializing a variable is when you declare it and you give it a starting value. You don't have to initialize every variable. What do I mean by that? It has to have a value before you can use it, but you don't have to initialize it. You don't have to give it a value right when you create it. Here, so far, everywhere I do this, I have been giving a value and a name. I mean, I have been initializing every variable as I go, but it wasn't necessary. Like string space best friend, semicolon. I could then say best friend equals, quote, Snoopy, end quote, semicolon. Our name must be Charlie Brown now. We didn't initialize it. We used it later though. Now NetBeans, being a little snarky, tells us if we give an unnecessary initialization. What do I mean by that? What if I just put equals quote quote like that, There's nothing wrong with that. It's absolutely nothing wrong with that. But it comes over here and it gives us a little warning. I guess when I control S it, watch, it's not going to give me a warning. Where's my warning? Okay. I swear it will. Int weight equals 32, semicolon, and then if I say weight equals 44, really? For 13 years I've been frustrated by the fact that if you give it a starting value and then you turn around and give it another value later, it tells you that that was useless, that that value was ignored, and it's not doing it now. All right, anyways, so this is initialization. This is declaration. This is an assignment. And initialization is a declaration when you give a variable a type, and an assignment all combined in one. And most of my examples up here have done that. Probably every single one of them. I wonder if I somehow configured it to hide that warning. Somebody show me. Somebody. Like type in int weight equals 30 on one line and then weight equals 40 on the next. Still on your mouse. What did you say?
I've been messing around with Python all day.
Yep. I switch between the two languages all day, and so yeah, weight equals 40. Semicolon. Control S it to save it. Is it going to pop up an error there? No. I mean, a warning. Okay, fine. Be different than you've been for the past few decades. I bet after today we'll start seeing it again. I don't know what's going on. So, int number, this is a declaration. Number equals 3, that's an assignment. Int number 2 equals 4, that's an initialization, which is a declaration plus assignment. Declare and assign in one statement. Now it's real easy, or at least I will, sometimes say initialize when I strictly shouldn't. Like if I start reusing the variable number for something else, I might say, okay, now I'm going to initialize it to 5, and then later on, now I'm going to initialize it to 0. No, I'm really setting it to 5, and I'm really setting it to 0. So numeric data types. Int and long are integers, so they only support whole numbers. And we've talked about the maximum value of an int. As long as it falls between -2 billion and +2 billion, we're good to go. It's because it supports powers of 2. Longs hold much larger numbers to the power of 18. Now this doesn't mean you can type in a number like that. Java does not have an exponent operator, unlike Python. I kind of wish it did, but you can't do this. Number is equal, or number 2 is, don't even bother because it's not going to work. 3 to the power 4? No, that's a syntax error. 3 up arrow 4? Okay, it's not calling that an error, but it really isn't 3 to the power 4. If we printed it out, this is not equal to 9, not in the least. So Java just doesn't have an exponent. Let's see what that does. System.out.println parentheses number 2. I bet it'll say 0. One. Okay, fine. I'm not going to even look up what that's doing. I think it's doing a so-called exclusive OR. A bitwise exclusive OR, if we want to start throwing fancy words in. We're not ready to start talking about bitwise exclusive ORs. Because I want us to get back to a point where we're doing real Java so that we can start doing real homework again. Ooh, see, I should have sprung a quiz on you guys. It's been wicked about the binary stuff. So a variable that needs a decimal place should be declared as a double. Doubles use 64 bits, whereas floats hold 32 bits. So doubles can hold much more precise. They hold up to 15 digits of precision and larger exponents, whereas floats hold 7 or 8 digits of precision, much less precise. We're just going to use doubles all the time. Assigning between different types. It's okay to assign an int into a float, but not vice versa. Then you remind me, have you taken C or C++?
Mm-hmm.
Okay. In some languages, like C and C++, it's okay to do something like this. Int xyz equals 3.5. Now, it's nonsensical to say that, because what happens? This can only support whole numbers. And so trying to put 3.5 into it is not going to work, right? It can only be a whole number, so it would round down. That's what happens in C or C++. In Java, it's just a syntax error. It just flat out tells you you can't do that. And that's a good thing for it to do, actually, right? Because it was nonsensical to try to store that. And you know, if I have a whole bunch of code and then later on, way down here, you know, 2 pages of code later, I try to set this equal to 3.5, I like it telling me that it's not a good data type for this number, right? Rather than the way C and C++ handle it, which is just go, yeah, no problem, I don't care. I'm going to store some numbers in there, I'm going to round it off, but you don't need to know. Well, it's good to know, so I'm glad that Java gives us an error. It says, incompatible types, possible lossy conversion from a double to an int. Well, yeah, boy howdy, since, you know, a double can have, you know, 15 decimal places and an exponent of up to, you know, 340 or 308 or whatever that max was, then there's no way that could store in a little bitty wimpy int, which has to be between a whole number between a positive and negative 2 billion. But the reverse is okay. Although this won't work, since that's an error, Java compiler will not let us assign a float into an int due to possible data loss. The decimal point would get lost, for example. For the other way is okay. Double xyz is equal to 3. No problem. You can take an int and store it in a double just fine. There's no data loss, right? That 2 billion will fit into a double just totally fine. So it's not going to warn us about it. It's totally cool, and it's not a problem that we used an int here and then stored it in a double. Now, if you've been programming in Python for 2 semesters, then you may be annoyed at the fact that you have to differentiate between them at all, because Python just cleanly switches from one to the other as it needs to. But we have to be very specific. We pick our data type, and then once we've picked our data type, only compatible data can be stored in it. I can't do this. XYZ is equal to 3. That's another error. Cannot store a string in a numeric value, numeric variable. So once you declare a variable, only data compatible with that type can be stored in it. Once you declare a variable, only data compatible with that type can be stored in it. Do I want to say that name is equal to 4? Too bad, I can't. Way up higher, I said that name is a string. Now, I could do something to get around that. I could put quotes around it, right? Now it's not a 4, really. We can't do math with it. We couldn't say, you know, y is equal to name plus 2, and I would actually say 6. But that would fix the error, and there's other things we could do too. But for now, I'm going to remove the quotes and say that's an error. name is already defined as a string. So the 4 would need to be converted to a string. So a constant is a value that can't change. There are two kinds of constants. There are unnamed constants, and then there are named constants. An unnamed constant is just one that's typed right into it. That's a constant. That's a constant. Because the only way it's going to change is if the editor grabs the source code, opens it up, and types in something else there, right? Snoopy is a constant. The user's not allowed to change it, right? The programmer would have to go in and change it. Same for Bob. Same for all of this stuff. Everything between quotes is a constant. All these numbers are constants because nothing's going to change it. On the other hand, XYZ is not a constant. We can turn around and change it if we want, right? XYZ is equal to 4.56. That's fine. XYZ is not a constant, so it can change. Those other numbers, the numbers we see, are unnamed constants, also known as literals. Or sometimes numeric literals. The only reason I can think of calling them a literal is because it's literally typed right into the code. There's a 3 literally typed right into the code. That's also known as hard coding. There's a 3 hard coded into the code. .56 is hard coded into the program. So if it needed to be something else, the programmer would have to edit the code to do so. And you really don't need to type in all my notes, and I know I type fast. But you can also have named constants. A named constant is a variable that is marked with a keyword, a special keyword, to indicate it cannot change. Python doesn't have named constants. So if you took fundamentals, we faked it by saying that if you see a variable with an uppercase name, you're supposed to treat it like it's a constant. But this language really does have them. In C, C++, the keyword was const, C-O-N-S-T. Java wanted to be different, so they made it final. So my final answer, no, final int height equals 6.5, whatever, feet, inches, I don't know. Well, that's an error. Why is that an error? I was dumb. Why is it underlining that in red?
Because you put a double.
6.5.
Right, so I better make it a double. Now it cannot be changed. If I try to turn around later and say height is equal to height times 2, no. Height was declared as a final, meaning that's its final value. It's never going to change. Or if you try to reassign it to something else, you try to say height plus plus or height equals 7, all of those will be errors. Height is a constant, so it cannot be changed. What do you use constants for? Things like tax rates or mathematical constants. You know, the value of pi is not supposed to change, so pi is declared as a constant. Now tax rates, you know, maybe you need to read them in from a file, so maybe they shouldn't be a constant. We'll talk more about when you would want to use them. You want to avoid what are known as magic numbers, or numbers that are used over and over and over inside your code, and then if you had to change it, you would have to change it in a whole bunch of places. Like if you had a tax rate, you know, and you wrote, 200 lines of code that used a tax rate of 7.5% in 20 different places. And then you decide that, well, I want my program to work, for my grandparents, and they live in a different county with a different tax rate. Too bad that you're going to have to go in and modify it and find all 25 numbers and change them all. Whereas if you made it a constant and put it up at the top of the code, you'd only have to change it once. Better yet is if you let them type it in. But nobody's going to type in the value of pi. It's a good thing to make pi a constant and just declare it once, because if you're typing in 3.14159 over and over and over, but once in a while you forget the 1 in the middle of it, then your answers are going to be inconsistent. So constants can be split into two categories: hard-coded constants and named constants. This is a named constant. Now, what in the world are the underscores here? I had forgotten you could do that. I think this takes me by surprise every time I teach. If you do this, double speed equals, you might want to say, like, I'm going to go 1,000,322 miles per hour. Right. Commas don't work. But Java made it so that you can use underscores as commas. I never, ever, ever do that, but the book just demonstrated it. So that is really 1,223. So on our example here, the cable length divided by this magic number is equal to the propagation delay. Now, if your program uses this magic number a whole bunch of the time, right, over and over in your code, it's silly to make yourself type it in over and over and over. What if you get it wrong in a couple of places? What if you get it wrong once? What if you have it 10 times in your code, and then you look up in a book and you found out that you got it wrong every single time, and you have to go and find all 10 instances? It should have been made a constant. This number should have been, put into a variable up at the top of the code. So a named constant is one that's got a name, like the speed of light. Final double speed of light is equal to 299,782, whatever. And then here's a helpful comment saying that that's meters per second. And then the propagation delay is equal to the cable length divided by the speed of light. Much better, much easier to read, right? I didn't know that that was the speed of light. I didn't recognize it. Maybe I should have, but I didn't. So what does final do? It tells the compiler to generate an error if your code tries to change it. Standard coding convention is to capitalize all the characters in a named constant, just like we see here, speed of light. That's just kind of an agreement. Just like fundamentals, we were supposed to use capital letters to indicate something was a constant. Well, really everybody does that no matter what language they're using. Two benefits of using named constants. The code is more understandable. And if the programmer ever needs to change its value, the change is easy. You just find where it's declared and you change it. That changes it everywhere that it is accessed. So arithmetic operators. We pretty much know what addition, subtraction, multiplication, and division are. There's one special case, which is that Java performs division differently based on whether the numbers being divided are integers or floating point. This will be the last thing we type in our code, because we're running out of time. But if I do this, system.out.println, parentheses quote, fraction equals, end quote, plus 2 divided by 3. Is it going to print 0.666666? It would in Python. Instead, it just prints 0 because both of these are integers. An int divided by an int equals an int in this language, and in C, C++, and C#, not in Python. So you have to kind of be careful. If your equation is this, the volume of a sphere is equal to 4 over 3 times pi times r cubed. So r times r times r. And you type that in, it's actually not going to work. Why? What's 4 divided by 3? All by its lonesome. If an integer divided by an integer is an int. It's not 1.333. It rounds it down, so what is it?
1.
It's just 1, and so it's Blitzstar formula. So that's worth making a comment of. That would be a calculation error because 4 divided by 3 is just 1. We should make it 4.0 divided by 4.0 divided by 3.0. Honestly, just making one of them a floating point would be enough, but why not make both of them? All right, so homework. Here we have the formula for the volume of a sphere. Write a program that calculates the volume of 10 spheres. Yeah, that's ridiculous. 4 spheres. Use a radius of 1, 10, 100, and 1,000. Display the results for each calculation. So for example, I'd like the output to say something like this. The volume of a sphere with a radius of 10 is 314.159 blah 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 blah. The formula you're going to want to use is volume equals 4.0 divided by 3.0 times math with a capital M dot pi, both of those are caps, times r squared, r cubed, so math dot POW, parentheses, radius, comma 3. That's r cubed. Now you can make it as clever or as unclever as you like. You don't have to make, you don't have to define a method or function to stick the volume calculation in. You don't have to try to figure out how to, create an array or a loop or anything that'll handle. You can just, calculate and print, calculate and print, calculate and print, calculate and print. That makes sense, gang. Alrighty.